Hello everyone, welcome back to our operating system series. This is lecture 3rd and today we'll be taking about I/O structure. Input output is one of the most important function of an operating system because it manages how our system interacts with external devices like keyboard, monitor, storage devices and network cards. So let's start with introduction to I/O management. The operating system plays a central role in managing input and output devices. Some examples of I/O input devices are storage devices such as hard disk and SSDs, input devices like keyboard and mouse, output devices like monitor, and even network cards for the communication. In fact, a large portion of the OS code is dedicated only to I/O management. CPU and devices controller are connected through a common bus, which is the medium of data transfer. Next is the device controller and drivers. To make this interaction smooth, the OS uses device controller and device drivers. A device controller is a hardware, basically a circuit, that manages a specific device. It usually contains buffer and register to hold the data temporarily. And the device driver is a software. It understands how the controller works and provides a uniform interface to the operating system. So whenever we plug in a device, it's a driver that allows the OS to talk to it. Right. So next is the process of an input-output operation, interrupt driven. Let's see how typical input-output operations work. Especially in an interrupt-driven system without using DMA, the process usually goes like this. First is the device driver loads command into the device controller registers. Second is the controller interrupts those commands and starts the operations. And third is the device is transferred into a buffer inside the controller. Fourth is once the operation is done, the controller sends an interrupt to the CPU. And last but not the least, the device driver then moves the data to the operating system and return control backs. This approach works, but it has a limitations, especially when we deals with a large amount of data. So in the next slide, we'll talk about the challenges with the bulk data. Interrupts driven input or output is efficient for the small data transfer, but it becomes a problem with the bulk data because in this system, the CPU has to handle every single byte of data. This creates a huge overhead and prevents the CPU from doing other important tasks. So for the large file transfer or the video streaming, this method is not a practical method. So the solution of this challenging the bulk data is a direct memory access that is called DMA. DMA allows large blocks of data to be transferred directly between the memory and the devices without involving the CPU in every step. So instead of the CPU babysitting every byte, the DMA controller takes over the transfer and the CPU is free to do any task. So what are the advantages using direct memory access or DMA? Instead of generating one interrupt per byte, DMA generates only one interrupt per block. Second is this reduces the CPU workload significantly. And the third is the CPU can perform other tasks in a parallel while data is being transferred. And the fourth is overall the system efficiency and performance improves greatly. That's why almost all modern systems rely heavily on DMA for large data operations. So to wrap up, in today's lecture, we explored how the operating system manages input-output, starting from the device controllers and drivers to interrupt-driven input-output, and finally how direct memory access improves efficiency. In the next lecture, we will move forward. If you found this lecture useful, don't forget to like, subscribe, and share for the more OS concept. See you in the next one lecture. Thank you so much.